Hello everyone. Welcome to the solution of LeetCode problem 222 named Count Complete Tree Nodes. In this problem, we are given a binary tree and we have to return the number of nodes presented in the binary tree. Additionally, we have to design an algorithm that runs in less than big O of n time complexity. So here in the first example, the root is 1, which has two children, 2 and 3. And 2 has two children, 4 and 5. And 3 also has one children, which is 6. So here we can see that in total there are 6 nodes available. So we have to return 6. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Here, the root is 1, which has two children, 4 and 2. 4 also has two children, 3 and 9. Now here in total, there are 5 nodes. So we have to return 5. But the question is, how can we solve this problem? The first algorithm comes into my mind is we can run any of the in-order, pre-order, or post-order traversal. And inside in each iteration, we will count the number of nodes. Suppose in the pre-order traversal, we are at this node. Now we will go left, left, then we will go up, then we will go right, then we will go up, and we will go root, then we will go right, and we will go up. So by using this pre-order traversal, we can find there are 5 nodes, but the problem is we have to visit each of the node, and if there are n nodes available, the overall time complexity of this algorithm will become big O of n. But in the problem statement, we are requested to implement an algorithm that runs in less than of big O of n runtime. So how can we solve it? The intuition is very simple. At first, we have to run the iteration from the root. Now, from the root, we will calculate the distance or height between the left value in the last level to the root, which is this. And here, we will again calculate the height of the right child in the last level from the root, which is this. Now, suppose let's add another node here. Let's say it is 3. Now here the algorithm will be much more intuitive. So here, the basic intuition is from the root, we will calculate the height between the distance between the root and the leftmost node of the last level, and we will calculate the distance between root and the rightmost node of the last level. So here, if suppose it is h1 and it is h2, and here if both of them are equal, that means we can say that the total number of nodes presented here is 2 to the power n minus 1. This is the basic intuition. And if both of them are not equal, suppose here these 3 is not present and these 3 is presented here. So in this kind of cases, we have to recursively call the DFS function into the left subtree, which is this, and into the right subtree, which is this, and add both of their return value plus 1. Why this 1? This is for the root. And this is how basically we're gonna solve this problem. So the algorithm is pretty simple. Let's wrap up. We have to run the iteration from the root, and we will calculate the distance between the leftmost node and the rightmost node with the root. And if both of them are equal, then there are 2 to the power n minus 1 number of nodes present. Otherwise, we have to recursively call the function into the left subtree as well as into the right subtree, and additionally add 1 as the value of the root. Finally, we have to return the answer. And the overall time complexity of this algorithm is big O of log n square. Here, log n is used to calculate the distance between the root and the left and the right subtree. So here, as we have to calculate both of the left and the right child height, so the overall time complexity will be big O of log n square. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named count nodes, which has a root as a parameter. Now, if the root is null, we have to return 0. Otherwise, we have to initialize with left height and right height with 0 and mark the L and R to root. Now here, we have to calculate the left height until the tree or the node does not have any of the left children. Similarly, we have to calculate the right height. Finally, if both of the height is equal, we have to return power of 2 to the power height minus 1. Otherwise, we have to return 1 plus recursively call the function into the left subtree and recursively call the function into the right subtree. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.